All right, so now that we know that the vertex formula or vertex form um, lets us see the different movements that will happen to a quadratic if we place different values in different sections. We're going to see why this form is so interesting. So I'm going to leave A as 1, and I'm just going to visually, oops, put a placeholder in there just to show you that A is 1. So I'm going to have x minus 2 power of 2. So as you can see, 1's not doing anything. This is my A. This is an h value of 2, but again, it's appearing in the equation as x minus 2. So the h value itself is positive, so it is going over to the right by 2. So we're shifting it all over right, and I've squared it, so this is a quadratic. And now I'm going to put plus 3. So it's actually shifted it over to the right by 2, and then push up 1, 2, 3 units. So you can see that my vertex is 2, 3. So you can see why this is called vertex form. I'm just going to click on the draw application. And because the 2, 3 is actually coming directly from the equation. So my h value is 2. This drawing application doesn't like when I do any curves. And the k value equals to 3. And this is, in essence, why this is called vertex form, because my vertex is always, always, always going to be at h8. Oh my goodness. So my, again, my vertex is always going to be at h, comma, k. So that means when you look at a vertex form equation, you can just always find the vertex right away by looking at it. This is why this form is so incredibly powerful. So we are going to try a couple. All right, so I'm going to try a few here. So I typed in one equation, and here we go. So y equals 2 x minus 4 squared plus 1. Again, just as a reference, I'm going to have my A, x minus h squared plus k, just available to me as a reference there. And so my A value here is a 2, so my A equals 2. Sometimes this really helps to put this down. Here we're analyzing this, it's my k. My k actually equals 4, not negative 4, because don't forget that negative is in that generalized form. And here we go, this one is my k, so my k equals 1. So I automatically, right here, know what my vertex is. Since my vertex is always h, comma k, I know, hey, right away, my vertex is going to be 4, comma 1. And as you can see, because I graphed it over here, it's moved from 0, 0, and right over here, 1, 2, 3, 4 units right, 1 unit up. That's exactly where my vertex is going to be. Okay, so in this example, I've just changed the equation a little bit from the previous one. And again, we're going to be looking at my A value is still 2. My H value has changed now. I see it as an X plus 3. So in reality, my H is a minus 3 in there. And my K is going to equal to 4. And again, I can tell where my vertex is. My vertex is going to be minus 3, comma 4. And in fact, it does verify with the graph. I'm going to start here. I'm going to go over 1, 2, 3 points to the left. And I'm going to go up 4 points. 1, 2, 3, 4 points up. That is my vertex.